Welcome to MyProjectBazaar.com. Now we can going to discuss about the product implementation of novel hybrid UPQC topology en- endowed with isolated bidirectional DC to DC converter or DC link. Now we can going to discuss about the abstract of our product. In the proposed system of hybrid unified power quality conditioner, this is a mainly alternative for solutions for power quality problems. Because of the entire power system, because a lot of distortions and a lot of harmonics problems and power losses, we can all things are considered about that. Specifically, we can our power quality we can improve the specific task of our entire power systems. If in case we can particularly using for the hybrid unified power factor conditioner, we can import some things our additional blocks and we can implement some electrical circuits and topologic architectures. And this is the first thing for we using for DVR. DVR is a dynamic voltage restorer and another thing is for SHAPF. This is a shunt hybrid active power filter and another one is for bidirectional DC to DC converter. This is abbreviated for BiDC. So this three combination process, this is entirely differentiate our system and very improve our noiseless of our power quality issues. We can improve our system to stabilize to getting the perfect of the delivery side of our consumer side. Because of we can using the DVR the dynamically voltage to restore our opposing of the DC link. The DC link is one very important of this step. Because of the DC link we can economically efficient compared to the batteries. Because of we can replace of batteries or DC link we can similar process we can using that, but our switching cost is very small because of every switching as using for the IGBT. Because of this is economically sufficient to getting the every most of our architectures. And then another thing we can see about the voltage sag and voltage swell of these combinations of every system. And we can some using the DQ transformation we can getting the for our frequencies to and deploy our to our frequency analysis. We can everything we can import out of this entire system of unified power system conditioner. This is to get really better to much the getting the results. Now we can going to discuss about the flow down of the product. First we can going to discuss about the AC grid. The AC grid is one of the energy storage and energy emitting system. Because of this is one of the grid also. This is a grid link is number of lines is connected into the single line to getting the some powers, and this is passed to the dynamic voltage restorer. The dynamic voltage is nothing but we can find out the voltage swell and voltage swags of the every phases and every lines. Because of this is our dynamically restore our every lines of the specific chargings and some settings will be automatically we can getting some process. So we can use in the dynamical dynamic voltage restorer for line injections. Then we can pass to the hybrid active power filter. Hybrid active power filter, this is for one of the filter process. Because of we can dynamic voltage restorer some harmonics and so voltage swell and low voltage are combined that. Because of this is for some some reduce the noise levels to getting the perfect output of the specific block. Then in the intermediate section of the isolated bidirectional DC to DC converter, this is for isolated bidirectional DC to DC converter for bidirectionally to act as for some linear transformations using to the our line stabilizations are linearly getting to perfection to getting to the active shunt active power filter. So we can using the another section for the sensitive load. Because this is sensitive load, because of this is nothing but single line load. Using some linear varieties of loads we can getting that of individual lines we can using the very low amount of power we can consume that. Next we pass to the non-linear load. Non-linear load is on for some RLC and combination of different parameters we can getting the non-linear load. and this is very important section of these three blocks. Because of this is on controlling the every block system. This is some switching pulse we given to the DVR and isolated bidirectional DC to DC converter and hybrid and active power filter. Everything we can get the switching pulse, some sinusoidal pulse with modulation, and some alpha to DQ transformation using that pulse given to every these three blocks. Because of this is very important to getting that our um, very perfect power given to deliver to the load. Because of this is an process to getting the entire power system and reduce the line losses and harmonics also. Now we can go and discuss about the running procedure of your product. The proposed system implementation done in Matlab version 2013a. First to open the Matlab window and create a new model file and creating elements as well as circuit diagram. This is for our main model is on our modeling of the entire process. This is our entire architecture of this modeling. Next I will show for architecture modeling. These are our entire architecture modeling for that, and the corresponding scopes are connected in the from two functions. These are our corresponding scopes, and every function we can getting some pulses, and this is control of DVR, bidirectional DC to DC converter, active powerful, and every switching pulses are connected in different parameters and different constraints, and we can getting for our implementation for novel hybrid DQ transformation links. Then we can go into running process. I will click the run button. This is on running. Yes, running process is done, and next you can see about the results. This is our grid current and voltage, because this is a given input for 5 into 20 to the power of 4. These are very high voltage, and this is very low current. Because of a lot of things are using the transformer intermediate section, we can using some step down, so we can getting that and the voltage is increasing, automatically current is also decreased. So because of we can getting the result, and use the exactly zoom, we can getting that zoom in axis of the scope plot. Next is this is for another scope block. This is all the load voltage and load current. Because of it is on getting that very strippy waves, and carry for the three phases. We can see that this is like that this scope of results. This is on voltage and this is on current. This current is on not purely getting that sinusoidal wave, so no issues, we can getting that results. Next this is for our sensitive load results. Our sensitive load results, and we can see that nearly we can for stripping waves and of every curve lines, and this is our sensitive load voltage, this is sensitive load current. Use the auto scale block, then we can see the results. This is the load of ABC. This is for our source, and the scope another plot. This is a switching pulse of the shunt active controller. We can this is our switching pulse of the 6 switches of GAT pulse for G1, G2, and G3, and G4, and G5, and G6 also. This is a DVR control results. This is an we are getting the 12 pulse switchings, and this is our 12 switches. Nearly we can getting the automatically it's once 0, and 12 switches and randomly off and on and off. We can getting the different kind of results. And then next another thing is for our switching pulse or bidirectional DC to DC converter. This is an F1 is an firing pulse, and F2 is an four different switches we can connect, and there is automatically 0 or 1s. We can getting the results for 0 and 1s. So we can enter architecture results. That's all.